So before we continue with question 5, let's do an easy one. I'll just make one up. X squared minus 6x minus 3 equals 0. Okay, so imagine we want to solve this problem. No problem, because we have a 1 here, which is good. We want to have x squared. Here we don't, so we've got to fix that later. So the first thing to do, move your minus 3 away to the other side. So I just want to have x squared minus 6x plus on this side, and then on this side, just have 3. So the number we're interested in is minus 6 here. And when we complete square, to complete square, we need to halve that number. So divide it by 2, then square it. So we'll get 36 on 4. Okay, so which gives you 9, like that. So we'll add this special number to both sides. So remember, this minus 6 is here. Halve it and square it, we'll get 9. This is the number we add to both sides. So minus 6x plus 9 here, and then add it to the other side here. So that's written on both sides. And the reason we did that is because now this is a complete square. So we can write this in the form x minus, and the square root of 9 is 3, all squared. So if you want to expand this, then you should get back to that there. And 9 plus 3 is 12. So what we could do here, there's a couple of ways we can go now. We can do the difference of squares. So first method, diff of squares. So if you actually want the factors, this is a good way to do it. If you actually want the factors. You may not want the factors, so if you don't want them, we can use the other method over here. So in this case, remember, we've got a square. The first thing to do is get rid of this square. And by doing that, we square root both sides. Remember that from last week? And the square root will cancel out the square. So we're left with x minus 3 equals plus or minus root 12. That's important. Don't forget this plus minus, because we have 2 solutions when you square root 12. Just to explain that again, remember, for example, root 9 can be 3, but it can also be minus 3, because 3 squared is 9 and minus 3 squared is also 9. That's why you end up with 2 roots, what they call roots here. Okay, so we have 2 possible answers. So the next step is bring the 3 across. 3 plus or minus root 12. You can stop there, but we can simplify the surd a bit. Remember last week I said root AB, it's the same as root A times root B. So root 12 can be written as root 4 times root 3. 3 fourths are 12. And root 4 is 2 root 3. So we can change this to 2 root 3, which looks a bit better. And then you can write that as a decimal as well if you want. And I don't have my calculator, so you can calculate that yourself. So this is if you're using difference of squares. Okay. Actually, that's not difference of squares. This is algebraic method. I'll do the difference of squares now. I guess I did that because I always use this method and I neglected to look at what I'm doing. So the other way, as I mentioned, is difference of squares. We'll do that here. So for difference of squares, it's a little bit more tricky here because you have 12. So we have x minus 3 squared equals 12. Now what we do, we bring the 12 to the other side. But then we need to make this to a power 2. Change your 12 to root 12 squared, which is 12. Okay, you've seen this before already. So, because 12 is not a perfect square, so we have to make a root 12, then square. So now we use our difference of squares rule. So a squared minus b squared, a minus b, a plus b, which you're familiar with. So then we would have x minus 3 minus root 12, x minus 3 plus root 12 equals 0. And when you solve that, you'll have two parts. X minus 3 minus root 12 equals 0. Therefore, x would equal 3 plus root 12, which is the same as up here. And this one, x minus 3 plus root 12. So x would equal 3 minus root 12, which is the same as this one up here. So you can do it that way as well, but I think really the quickest way is this algebraic method here, taking the square root of both sides and then rearranging it. Difference of squares, you can see, takes a lot more work. So I don't really recommend this method. We would use this method if we want the factors. And you can see the factors are down here. All right. But you can get the factors from here as well, just working backwards. Anyway, so that's a simpler example that we did last week. So for this one here, remember you can review the video, and also for the videos, I put them on the YouTube already. Okay, so you go to your playlist, and I put these in the playlist already. So that's what I did on the weekend. I moved them to YouTube. Okay, so for this question here, we've got a 2. So we don't like numbers that are not 1 for this method. So we've got to divide everything by 2. So that's the first step. So then I'll end up with x squared on this side. So x squared minus 7 on 2x plus 3 on 2 equals 0. Okay, so this is your constant number. So we'll move this out the way first. So you'll have x squared minus 7 on 2x equals minus 3 on 2. Okay, so your special number comes from this one. We halve this number and we square it. So let's do that separately. So halve this number and square it. So you'll end up with minus 7 on 4 squared. When you divide 7 on 2 by 2, you get 7 on 4. And then square that, you'll get 49 on 16. Okay, so this is your special number that needs to be added back here. So we'll do that. So x squared minus 7 on 2x plus 49 on 16. That will help you complete the square. Equals 49 on 16 minus 3 on 2. So I just put that in the front here. Okay, so now our complete square will be x minus, so x comes from here, the minus comes from here, and this number will be the square root of 49 on 16, which would be 7 on 4 all squared, because root 49 is 7, root 16 is 4. So just square root top and bottom. Now this here, 49 on 16 minus 3 on 2, will be 25 on 16. So you can put that in your calculator or do it the long way, but you'll get 25 on 16 for that there. Just come up a bit. Okay, so I think at this point, we'll use the algebraic method as we did here. So square root both sides, and that will become plus or minus. And then we'll have x minus 7 on 4 equals plus or minus. Now root 25 is 5, root 16 is 4. And I just took the square root of top and bottom there, that one. So then basically your minus 7 on 4 will come to the other side. So x equals 7 on 4 plus or minus 5 on 4. So you can see there's going to be two answers, 7 plus 5 on 4, which is 12 on 4, which is 3. And then you've got 7 on 4 minus 5 on 4. So 7 minus 5 on 4 from this one here, the negative sign. So you get 2 on 4, which is a half. Okay, so they're your two solutions, 3 and a half. Now, as I just mentioned earlier, you can get your factors from these. I'll show you how to do that. So these are your roots or your solutions. The roots of the equation. You'll sometimes hear that word roots. So important word, roots. You'll see this word here. I don't think they use it much in the book though. Okay, so if you've got x equals 3, now we can find the factors from the roots. So if you've got a root x equals 3, put the 3 on the other side, like that. I just moved the 3 over. That there is your factor. That's the original factor. Remember, you know how to get from here to here, don't you? We can go backwards and forwards between both of them. In the second one, x equals a half. So what I would do here, I'd multiply both sides by 2. So you get 2x equals 1. So times 2, like that. So 2x equals 1. And then that would give you 2x minus 1 equals 0. So that's your factor that you would have had. So that shows me that this question could have been factorized as well. And your two factors were x minus 3, 2x minus 1. Okay, so those would have been the factors to that question. So in a test, I would not do this method here. I would factorize better. So factorize quicker. Factorizing would have been better for this question, but not this one here because you've got root 12. So that one would have been difficult to factorize easily. Okay, so we'll skip exercise 2 because that's just a bit on factoring and there's only a few questions there. So what you can do now, go look at question 1, exercise 3. Okay, so open that up. In the first 3 questions, you will see it's already a complete square like that. So that's good. This is easy to solve now. Let's do the first one. You've got a power 2. So algebraic method I would use because it's quicker than factoring. So then take the square root of both sides. You can finish those 2 and 3 there. So take the square root of both sides. You'll get a plus or minus here. Don't forget that. So you're going to get 2x minus 1 equals plus or minus root 16 is 4. Okay, like that. And then I want to put my minus 1 to the other side. Like that. And then I will divide by 2, won't I? Like that, just both sides. So you're just rearranging the equation. And then you'll get x equals 1 plus 4 on 2. And you'll get 1 minus 4 on 2. Like that. So then you're going to get 2 answers. 1 plus 4, 5. 5 on 2, just 2.5. 1 minus 4 is minus 3 on 2. Like that. That's your solution. So you don't have actually much space to write here. So I recommend if you're using a tablet, just write out here somewhere and then write your answer in here, because I don't think you'll have space on the other questions to do that. Okay, this one's okay because it's not much. But when you come to question 4, you may need some space for writing. You can just write the answers in here. Okay, only write in here if you have space. I'm not marking this, remember. This is your personal work for your practice. All right, so I'll let you do 2 and 3. When you come to 4, I'll wait for you to, you can think about that yourself for a while, okay? So work for about 10 minutes and do a few of these here and see how you go. So you can keep working, but in question 2, we'll do a bit of that. Just run out of space is the only problem here. So you should take the square root of both sides as before. So you'll get 3x plus 7 is plus or minus the square root of 25 on 49, which is 5 on 7, like that. So 3x equals minus 7 plus or minus 5 on 7, and then divide that by 3. Like that. When you rearrange this, you'll end up with x equals minus 6 and minus 7 5/7. So that's your answer there. That's what you get by rearranging that. 3 cut there. 3 will go down. So rearrange this, put in your calculator, you should get that answer there for that one. In question 3, we do the same way. Square root, square root. So you get 2x minus 3 on 4 equals 7 on 5, plus or minus 7 on 5 here. So when you rearrange this one, x will be minus 13 on 40 and 43 on 40. So I won't show all of that because there's quite a lot of things going on there with that one. But just use your calculator to rearrange again. That one's a bit difficult because the numbers are fractions. So that's your answer for that one. Those ones are just rearranging. But question 4, x squared minus 6x plus 1. So I'll show you a bit of this. I'm going to write here, but I'm going to rub this out. So if you want to copy this, you will need to copy it now because I'll erase it when I go further down for some of them other ones. So x squared minus 6x. Now put your 1 on the other side, give -1. So your middle number here is -6. So now we need to complete square. So halve that number and square it, you'll get 9. So this is the number you need to add to both sides. So x squared minus 6x plus 9 equals -1 plus 9, like that. So you need to make this a complete square. X minus 3 all squared. Okay, equals 9 minus 1 is 8. So now we have this same situation in question 1 to 3. So now we will square root both sides. Like that, cancel your square as usual. So x minus 3 is plus or minus root 8. Bring your 3 to the other side. So x equals 3 plus or minus root 8. You could finish here, but remember the rule AB. Root AB is root A times root B. So we can make the root 8 root 4 times root 2. So that's 2 root 2, same. So x will equal 3 plus or minus 2 root 2. So you can leave it as root 8, but get used to simplifying here. And your calculator will do that as well. So I'll write the answer up here. So if you're copying that down, do that quickly. X equals 3 plus or minus 2 root 2. And you can write as decimal as well if you want. So that's your answer there for that one. That's the working here. Okay. Do question 5 the same way. I'll leave that for a minute and I'll rub it off. So in question 5, you can see that the 2 is already on the right side. So we do the same here. Let's write this again. X squared plus 6x equals 2. So the middle number is 6. So we halve and square that number. We'll get 9 again. Add that 9 to both sides. So x squared plus 6x plus 9 equals 2 plus 9. Okay, so calculate your special number, add that to both sides. You must add to both sides to keep the equation balanced. Otherwise, the equation is not the same anymore. So this here means that now we can write the complete square. We have an x plus root 9 is 3 all squared. So square root of 9 here for that one. And that's 9 plus 2, 11. So you can copy this down if you're a bit slow. And this will help for tomorrow. So now we have our perfect square. So why don't we just square root both sides like before, and we have plus minus, and then cancel your square. So you'll have x plus 3 is plus or minus root 11. Then the 3 just goes over. So x will equal minus 3 plus or minus root 11, like that. Okay, that's the answer to that one there, question 5. So I'll write that up there. So if you're copying that, you write it down. So that's x minus 3 plus or minus root 11. That's question 5. If the time runs out, I'll just give you the answers to the other ones, and then you can try them yourself. All right, so if you're copying that, write that down, and then we'll do another one. So for question 6, we'll do the same way, except it's a bit more complicated because you have 7 and it doesn't divide evenly. So let's try. So x squared plus 7x, bring your -3 over to become 3. Get that out of the way first. Your middle number is 7. So we need to halve and square that number to give us a special number, which will be 49 on 4. So just leave it like a fraction. So add this number back to your equation. X squared plus 7x plus 49 on 4 equals 3 plus 49 on 4. So this is your complete square here. You have x plus the square root of 49 4 is 7 on 2 all squared. So square root that number there. So square root 49 7, square root 4 is 2. Then this side, I will make a common denominator. So I write this as 12 on 4 plus 49 on 4. Okay, 3/4 of 12. So these are the same. And I did that so I have a common denominator. So we'll have x plus 7 on 2 squared is 61 on 4. Okay, just add the numerator and denominator is common. So now we square root both sides as usual. And we'll have plus or minus. So you're going to cancel your square here. You'll have x plus 7 on 2 is plus or minus, now root 61 on root 4, and square root 4 is 2. So do you see what I did here? I square root the 61 on top, on the numerator, and square root 4 is the denominator, which is 2. So your calculator can all do this as well. I just show the working when you submit work. So x will equal minus 7 on 2 plus or minus root 61 on 2. So notice now you have a common denominator here. So we can join this to one term. So minus 7 plus or minus root 61 on 2. And you can make a decimal if you want, but this is okay for the answer. That's your answer there then. That one there. So I'll leave that there a minute, because tomorrow you'll be doing similar ones tomorrow by yourself, mainly by yourself tomorrow. Okay, we have a few more minutes. I'll give you the answers to these other ones, and then you can check yourself. So just copy that one if you're copying. So your answer up there is minus 7 plus or minus root 61 on 2 for question 6 there. So question 7, if you do 7, you've got a 2 here. So you'll need to divide everything by 2 first. Okay, so try that one. That one's not too bad. This one you can try, see what happens. This one has a 4, x squared. So you don't want 4 with x squared, you want 1. So we divide everything by 4. Or this method won't work, or it gets quite complicated. Now in question 10, bring your minus x over. So 5x squared plus x equals minus 20. And then try the same way and see what happens. That one will have fractions too in some of the calculation. So we only have 5 minutes. So near the end of the lesson, I'll write the solutions and then you can practice yourself. And some of them may not have any real solution as well. You'll see. So for some of these answers, question 7, for example, you should get x equals -2 plus or minus root 10 for your final answer. And as a decimal, minus 5.16, 1.16, which is okay as well. You can show the decimal. Question 8. When you try to solve this, you get no real solution. You'll end up with something plus or minus something, which is a negative number. So under the root sign, you may find you get a square root of a negative number here, like -2, -3. I'm not sure what it is, but that will be no real solution for this one because of this square root negative. So no real solution for this one. And there's a way we can quickly check that. We'll do that in the next section when we do the next topic. Okay, that's question 8. Question 9, we end up with x equals 2 plus or minus root 3 on 2, which is 0.13 and 1.87. So check you can get these. If you've already done your homework, you should play with these a bit and try and get them to work properly. And this one here also has no real solution because of this root negative number here when you try to solve it. No real solution in this one. And that does happen sometimes. And when we start talking about graphs, you'll see why with the graph, why there's no solution for those as well. It's like saying x squared equals -1. Remember, you can't square a number and get a negative number. And this would be solved by going root, like before, plus or minus. And you can see there's no way to get a square root of a negative number. In your calculator, you get error. So in that case, no real solution. It has a solution, but it's not a real one, which you'll learn about later. Okay, we'll stop there and I'll talk to you tomorrow. Tomorrow we'll continue on this section here.